Okay, a common mistake is to look at the equation, and the equation we're looking at is this one over here, and to start thinking that there's restrictions on the solution set if it's real. And the common mistake is just to look at the roots, and let's go through that, all right? So x minus 1 over x greater than or equal to 0, and this is a real number system, so what we get? We get x squared minus 1 over x greater than or equal to 0. If you look at this over here, looking at the zeros, plus or minus 1, it's minus 1 and 1, and 0 certainly at the bottom. I would shade the minus 1 in because it equals 0, and the 1 equals 0. Some simple sign analysis after one, like pick 2, it's going to be positive. If you pick a number between 0 and 1, like 0.5, it's going to be a negative number, so I'm not going to shade that in. Pick a number like minus 0.5. What would you get? On top you get negative, and bottom you get negative, so I'll shade that in. And then if you go below minus 1, like minus 2, you're going to get a negative number. So the domain of the first one, the numbers have to be between minus 1 and 0, and then goes from, let's see, 1 to infinity. All right? So let's do the second one. Not so bad. Let's write that down. The second one's going to be 1 minus 1 over x. Whoops. 1 over x. Also has to be greater than or equal to 0. And then what we get over here, let's write this down. This is going to be what? X minus 1 over x greater than or equal to 0. Again, number line goes down. What goes on a number line is zeros. That would occur at 0 and 1. And let's see, if you chose like 2, oh, by the way, at 1 it's going to be 0. I'll shade that in. And if you looked at that, let's put it in the same, so we can compare these things. And 1, shade that in. A number after 1 that you would pick would be like 2. That would clearly be positive, so that gets all shaded in. And 0, right? A number between 0 and 1, like 0.5, plugged it in. You get a negative number. And then, it's not lining up again. I just noticed that. I want them to be in line, so 0's here. And then we get, below 0, like 0.5, minus 0.5, if you plugged it in. Again, we're plugging it in over here. That would give you a negative over negative, which is a positive. So it goes like this over here. All right, so this is where sometimes look at this, the domain must be the intersection of those two sets. And they would write this down over here. Minus 1, 0, not including 0, union 1 off to infinity. And I point this out here that, some students incorrectly say that the domain of this problem there is what I just stated. All right, that's not true, by the way. And let me tell you why it's not true. All right, the reason it's not true is we have the sum of two roots. All right, let me just emphasize this over here. This is a root, and we're summing two roots together. What do I know about that? I know the x has to be greater than or equal to 0. So the only possibility over here is this has got to be thrown out. This is the only possibility now. So the domain of the real set is just those numbers there, from 1 to infinity. All right, now someone says, is that important? It's kind of important because we were looking for a real number solution to the problem, and the only real numbers that could satisfy us are the numbers 1, including 1 and forward. All right, thank you.